In this lecture video, we are going to talk about the evolution process. Software evolution processes vary depending on the type of software being maintained, the development processes used in an organization, and the skills of the people involved. In some organizations, evolution may be an informal process where change requests mostly come from conversations between system users and the developers. In other companies, it might be a formalized process with structured documentation produced at each stage in the process. System change proposals are the driver for the system evolution in all organizations. Change proposals may come from existing requirements that have not been implemented in the release system, or they may come from requests for new requirements, or from bug reports from system stakeholders, or from new ideas for software improvement from the system development team. The processes of change identification and system evolution are cyclic and continue throughout the lifetime of the system. And this is illustrated on the diagram on the left side of your slide. So you have the change identification process, which is the process of identifying the need for change and assessing the impact of this change. And then you propose this change. And if the proposal is accepted, you go through a software evolution process, which we will study in detail in the upcoming slide. And then you incorporate the evolution and build or deliver the new system. This diagram shows you the software evolution process of this change proposal. Okay, let's study the software evolution process in detail. This shows an overview of the evolution process. The process includes fundamental activities of change analysis, release planning, system implementation, and releasing the system to the customers. The cost and impact of these changes are assessed to see how much of the system is affected by the change and how much it might cost to implement the change. If the proposed changes are acceptable, a new release of the software system is planned. During the release planning, all the proposed changes, that is, changes may come from fault repair, from platform adaptation, and system enhancement, are considered. A decision is then made on which changes to implement in the next version of the system. The changes are implemented and validated, and a new version of the system is then released. The process then iterates with a new set of proposed changes for the next release, and so on. Ideally, the change implementation stage of the process should modify the system specification, design, and implementation in order to reflect the changes to the system. New requirements that reflect the system changes are proposed, analyzed, and validated. That is what you can see in this diagram, which says change implementation. So this is nothing but this phase, change implementation, that is elaborated here. So when there are changes proposed, the requirements are analyzed and updated, and this leads to the implementation or development of new software. System components are redesigned and implemented, and the system will be retested. If appropriate, prototyping of the proposed changes may be carried out as a part of the change analysis process. Now, this is the regular traditional method of implementing changes. But change requests sometimes relate to system problems that have to be tackled urgently. The urgent changes may arise from one of these three reasons. If a serious system fault occurs that has to be repaired to allow normal operation to continue, or if the changes to the system's operating environment have unexpected effects that disrupt the normal operation, or if there are unanticipated changes to the businesses running the system, such as, say, the emergence of new competitors or the introduction of new laws that affect the system. In these three cases, the need to make change quickly means that you may not be able to follow the formal change analysis process. Rather than modify the requirements and design, you may make an emergency fix to the program to solve the problem immediately. So this is the process of an emergency request. There is a change request that is coming up. You analyze the source code, you modify it, and you deliver the modified system. There is no formal process of analysis, updating, documenting, but it's an emergency repair process. However, the danger is that requirements, the software design, and the code eventually will become inconsistent because you have not documented or analyzed it completely, but you have focused on providing a quick fix to the problem. Although you may intend to document the change in the requirements and design, additional emergency fixes to the software may then be needed. And these emergency fixes will take priority over documentation. Eventually, the original change is forgotten and the system documentation and code are never realigned. Emergency system repairs usually have to be completed as quickly as possible. You choose a quick and workable solution rather than the best solution as far as system structure is concerned. This accelerates the process of software aging so that future changes becomes progressively more difficult, maintenance costs increase, and eventually the system will degrade. Ideally, when emergency code repairs are made, the change request should remain outstanding after the code faults have been fixed. It should not be considered or marked as completed even though you have repaired the system for urgent requirements. Since you are leaving the request outstanding, it can then be re-implemented more carefully after further analysis. An alternative, better solution to the problem may be discovered when more time is available for analysis. So, since it was an emergency repair requirement, you provided a quick fix, and once you have fixed the issue, you can actually sit back, analyze, and do it in a more formal and structured way. Agile methods and processes may be used for program evolution as well as program development. In fact, because these methods are based on incremental development, making the transition should be seamless. Techniques such as automated testing are useful when the system changes are made so that as and when you change the system is tested entirely again from the beginning. In short, evolution simply involves continuing the agile development process. However, problems may arise in situations in which there is a handover from a development team to a separate team responsible for evolution. There are two potential problematic situations under these circumstances where your development team is different from that of the team responsible for maintaining and evolving the software. First one, where the development team has used an agile approach, but the evolution team is unfamiliar with the agile methods and prefers a plan based approach. The evolution team may expect detailed documentation to support evolution, and this is rarely produced if an agile approach is used for development. There may be no definitive statement of the system requirements that can be modified as changes are made to the system. Secondly, where a plan based approach has been used for development, but the evolution team prefers to use agile methods. In this case, the evolution team may have to start from scratch developing automated tests, and the code in the system may not have been refactored and simplified as expected in an agile development. In this case, some re-engineering may be required to improve the code before it can be used in an agile development process. So in this lecture video, we saw what change identification and evolution process looked like. We elaborated the software evolution process. We also saw how to implement change, and we also saw the emergency repair process, the drawbacks of emergency repair process, and how we can overcome this problem.